Mankind has been looking up at the stars for centuries, wondering what lies out there in deep space and if there exist other intelligent species just like ours. Many years ago, Galileo started the journey to the edge of the universe using his handmade telescopes. But when that was not enough, advanced technology led to the creation of space probes so he could get a better look at our solar system and beyond. The Voyagers are two of the most famous spacecrafts that humanity has ever created and launched into space, and they're still making their way through the galaxy. One of them, Voyager 2, was thought to be dead for nearly a year, but suddenly it tried to make contact with us again, and it was successful. Now fasten up your seatbelts to find out more about these amazing spacecrafts, the incredible things they found, where they are now, how far they have traveled away from us, and where they are headed. In the history of spaceflights, only 5 spacecrafts launched by humans have gained enough speed to depart our solar system. The Voyagers are 2 of these spacecrafts, and they discovered more than we expected and survived far longer than NASA had planned. Officially approved back in 1972, the Voyager project was originally called Mariner Jupiter-Saturn, and the probes were previously named Mariner 11 and Mariner 12. But NASA decided to change the names because these 2 new probes had achieved significantly more than the spacecrafts of Mariner family. In other words, they were much more advanced. Now, while we're discussing this subject, let us understand the really interesting technology and hardwares of these vintage probes. These spacecrafts were launched an astounding 44 years ago, Voyager 2 on August 20, 1977 and Voyager 1 2 weeks later on September 5, 1977. This was at a time when important advances were being made in the science of gravity-assisted orbital trajectories, or in other words, the ability for spacecrafts to use the gravity of a nearby planet to give it a large boost in velocity as long as the spacecraft follows the intended or mapped out orbit. Let's start with the computers, which are identical in both spacecraft. Each computer system aboard the Voyager spacecraft is dual redundant, which means there are 2 of everything in case one fails. The computer aboard the Voyager probes have a combined memory capacity of just 69.63 kilobytes. That's barely enough space for a standard size JPEG photograph. The scientific data from the space probe is encoded on an old-fashioned digital 8-track tape device. They are, however, not the same as your grandfather's 8-track stereo in his classic muscle car. There are no actual example, nor is there anything in a museum anywhere, but we do have a photograph of it. Yes, this is the data cassette recorder for both Voyager spacecrafts that was subcontracted to Lockheed and built by Odetics Corp. It could record data at 2 different speeds, 115.2 kbps and 7.2 kbps. Playback topped out at a much slower 57.6 kbps with 33.6, 21.6 and 7.2 kbps being options as well. It's unknown what the magnetic tape was made of or what secrets were implemented to preserve it from deteriorating in the harsh atmosphere of space. Whatever those secrets were, they appear to have worked, since the DTRs in both spacecrafts operated flawlessly from the launch to the whole Grand Tour mission, as well as the extended mission that sent both of the spacecrafts beyond our solar system. The processor of the Voyager spacecraft can process around 81,000 commands per second. Your smartphone, which you are most likely using to watch this video, is roughly 7,500 times quicker. They send data back to Earth at a rate of 160 bits per second. To give you an idea of that pace, it would take around 8.5 years to download a 5 GB movie from Netflix with this download speed. But the most remarkable thing aboard each Voyager spacecraft is something no other spacecraft has: a golden gramophone record. These 2 gold-plated discs have 115 analog encoded images, greetings in 55 languages, a 12-minute montage of Earth noises, and 90 minutes of music. These were created in the event that one of these probes is discovered by an alien civilization. Powering each spacecraft, there are 3 plutonium dioxide, radioisotope thermoelectric generators or RTGs mounted at the end of a boom. Each probe was fitted with 11 different scientific instruments, which, if I explained in detail, would take easily over an hour. Instead, let's take a look at some of the remarkable discoveries made by the Voyager probes, as well as the photographs obtained throughout their travels utilizing these equipments. Both spacecrafts have been moving at a separate speed and on distinct paths. Voyager 1 is traveling faster at around 61,115.07 km per hour than Voyager 2, which is traveling at 56,327.04 km per hour. Voyager 1 captured incredible images of Jupiter, Neptune, Saturn, and Uranus. Voyager 1 was lucky enough to capture an incredible image of Jupiter's moon Io, where a volcano was seen erupting from the surface. It was the first time ever that an active volcano had been seen elsewhere in the solar system. But the most famous image Voyager 1 captured was of the Earth from Saturn, or what Carl Sagan called as the pale blue dot. This image was taken on February 14, 1990 from a distance of 6 billion kilometers away and inspired the title of Carl Sagan's book, A Pale Blue Dot, a vision of the human future in space. On the other side, on April 24, 1979, Voyager 2 began transmitting photographs of Jupiter that were stacked together to reveal a time-lapse video of the gas giant's atmospheric circulations, including the legendary Great Red Spot that is 3 times the diameter of Earth. Voyager 2 was able to do this by making closer approaches to Jupiter and the Jovian moons. Voyager 2 sailed by Triton, one of the Neptune's moons, on August 25, 1989. The data from Voyager 2 was utilized to create this film of Jupiter's spectacular encounter, which showed us Jupiter in a way we had never seen before. Voyager 1 and 2 examined all of our solar system's big planets as well as 48 moons, a unique ring system, and the magnetic fields of each of the outer planets. But as you are about to discover, this isn't all Voyager 1 and 2 would uncover. In reality, they would come upon something considerably more enigmatic and unknown, something for which they were not even prepared. On August 25, 2012, Voyager 1 became the first human-made object to enter interstellar space. As Voyager 1 exited the heliosphere, which is a vast bubble of charged particles that the Sun pushed around itself, the probe detected a 1,000-fold decrease in heliospheric particles and a 9% increase in galactic cosmic rays that comes from outside the solar system. Since entering the interstellar space, Voyager 1 has returned data about the circumstances in this remote region of the cosmos. One of these findings is that the cosmic radiation out there is quite powerful, demonstrating how charged particles from the Sun interact with the particles generated by other stars and how this bubble of charged particles protects everything inside our solar system from those lethal cosmic rays. On November 5, 2018, Voyager 2 became the second spacecraft in history to reach interstellar space, when it also detected a rapid drop in solar wind particles emitted by the Sun, as well as an increase in galactic cosmic rays and the intensity of the interstellar magnetic field. Engineers were once again astonished when Voyager 1 successfully utilized its backup thrusters to position itself so that we could speak with it back here on Earth in December 2017. Those thrusters hasn't been used since November 1980 during Voyager 1's flyby of Saturn. How's that for reliability? The Voyager probes are constantly transmitting data. Each probe includes a radio transmitter with a power output of 22.4 watts, roughly the same as a small refrigerator light bulb. The incredible part is that by the time its signal reaches us, the power has been depleted to less than 0.1 billionth of a watt. That's so small that NASA has to combine its Deep Space Network array of massive radio antennas, which consists of 3 facilities spread around the world: the Madrid Deep Space Communication Complex, the Canaveral Deep Space Communication Complex in Australia, and the massive 70-meter antenna at the Goldstone Deep Space Communication Complex in Barstow, California. NASA's deep space tracking antenna, which are placed all around the planet, have extraordinary sensitivity. The massive antennas must catch Voyager's data from a signal that is so feeble that the power impacting it is just 1 part in 10 quadrillion. A smart electronic digital watch has a power output of 20 billion times that of the incredible low level. But we have not finished talking to the Voyagers yet. After a 7-month gap, mission controllers issued a sequence of directives to Voyager 2 on October 29, 2020. The spacecraft had been flying alone while the Goldstone Deep Space Communication Complex's 70-meter antenna was being repaired and improved. The incredible thing is that, despite the passage of time, the fact that the Voyager 2 is now in interstellar space, it sent back a signal verifying receipt of the call and completed its new directives flawlessly. As of February 2022, Voyager 1 is 23.4 billion kilometers away from Earth and Voyager 2 is 19.4 billion kilometers from us. To save power, the majority of the instrumentation on each of these probes have been turned off. Now, they are heading towards their next destination. In the year 40,272 AD, Voyager 1 will pass within 1.7 light-years of an insignificant star in the constellation of Ursa Minor, named AC plus 79 3888, which is located in the constellation Ophiuchus. And in about 40,000 years, Voyager 2 will come within about 1.7 light-years of a star called Ross 248, which lies in the constellation of Andromeda. But sadly, and much sooner than this, we'll lose contact with both of the spacecrafts for good, and they will pass silently into the interstellar void. It would be fascinating if, in the far future, a civilization discovers a Voyager and learns how to power it on again. If that's the case, the ancient gear may come to life one final time. Keep an eye on my channel to see whether the Voyagers discover anything new, as well as to keep up with all the interesting events taking on in our universe. Thanks for watching.